Chapter 19. It is the same problem that you see here. We treated this before using assemblies. So I'm going to repeat the same problem, but everything is made within a single part. It's entirely up to you how you want to do this thing on a test, as long as you use all planes of symmetry and if you're instructed to do so, and you basically solve the problem that we're asking. I will not be using any planes of symmetry here, so everything is made from scratch as a single part. So let me start with a part file. Okay, and my first task is to create that let's say cylinder. So I'm going to go to part design. Okay, same dimensions and everything before. On a convenient plane, I'm going to draw a circle of radius, I believe radius 0.5 or diameter 1. It's exactly the same dimensions that we were doing before. So diameter 1, exit, and then I'm going to pad this thing in both directions. I think I used the height of, if I'm not mistaken, 2. May have been 1.5. I'm not sure. 1.5. Okay, so this is done. Now, what I would like to do is to create that horizontal plane here, or plate here. So I'm going to switch to wireframe and surface design. Where is that? Mechanical design, wireframe and surface design, or you can do generative shape design if you wish to do so. So on that plane, I will sketch. Sketch the contour of the plane plate that we're going to make, like this, and like so. Okay, clean it up. Top line, control bottom line, control middle axis. You make it symmetric. Okay, let's make the give it dimensions that we had before. So this is going to be 2, I believe. It was 2, and this was 2 also. Okay, and exit. Now we're going to use fill to, you're going to use fill, look for fill here, right here, fill to select the sketch and put a surface on it. Okay, now I just noticed that this height does not look like what we had before, so maybe the height was actually too high. I said 1.5, so 3 in total. So maybe I should have done 1 to be in line with the previous 2 video segments. Okay. The computer went into coma. Just give it a second. Okay. So it's this path that I actually wanted to be 1. Yeah, I think this is more like what we had before. That's fine. Okay. So now we want to make a hole in that. Notice that there is no hole here. Okay, so what we like to do is we want to make a hole in that plate, and the easiest way is to on that plane you sketch and you project that circle. Okay, so exit. Notice that if I hide this, I have a surface and I have a circle here that I can cut it with. So where's the saw for wireframe and surface design? It says element to cut is this, and the cutting element is right there. Okay, so notice that these are all within a single part. Okay, now let's go and create our lines here. So create a line, point and direction. The point is right here. The direction is direction Z. And I think I made a height of 3, if I'm not mistaken. Yeah, okay, it may have been height of 2, I'm not sure. Oh yeah, actually this may have been a height of 2. Okay. Yeah. And then another one, another line. Point and direction. This is the point. The direction is Z. And the height is 2. These are exactly the steps that we followed before, except that we created a part for that, a part for the plate, a part for the left column, and a part for the right column. Now these are all within the same part. Okay. Now let's apply material to all of these things. Metal, I think we made that out of steel, if I'm not mistaken. Yeah, everything is made out of steel, and we can close it. All right. Okay. So file, save management, save as, desktop, new folder, single part, chapter 19, single part. Incidentally, you can see that I'm not using planar symmetry. Single. All right. Okay, so now we're going to go to generative structure analysis. CATIA immediately meshes the cylinder. Immediately meshes. Let me hide these sketches. I don't need this, and don't need this other sketch. All right. Now let's mesh the sheet or the plate. So you have to do that yourself. There we are. And let me make this thing point, I don't know, 0.2, 0.1, something like that. I think I used 0.1 in the previous one. So I'll do the same thing, 0.1. Okay. And give it a thickness, same thickness that we had before. All right. Now we're going to do the beam mesh for these. The beam mesher right there. So we select this. Okay. And then we do it for that one. Okay. And then we define the cross section. This was already rectangular, correct size. So let me apply it to this. And for size is correct. So for the orientation point, I select this other point. Notice that it turn it around and it puts it in the proper orientation. And do the same thing on this side. And for orientation point, select this other point. It's also turned around. You can see it's in the right orientation. All right. If you look at the mesh, you're going to see everything there. All right. For example, let me change the color of this just like I did in the earlier video segment, and color of that, just for visual purposes. They play no role in the calculation. Green. Okay. Very good. Now let's save the analysis. File, save management, save the analysis in that same folder. Chapter 19, oh, not here. So let's go to the desktop. Where is that? Chapter 19. I think single part. Can't remember what the name. Oh, let's see if we can. Oh, right here, single part, right there. Okay, deactivate the mesh. Let's apply a clamp to the top point here. Another clamp to the top point there. We could have combined all of these. A clamp to the bottom of that. Okay. A pressure on the top face. Right there. That's correct. And we have to create two connections, one between that circle and the surface of this, and two connections for these columns. Okay, so let's carefully do this thing. This is going to be for a cylinder and plate. First component is going to be the surface of the cylinder. Second component, I'm going to hide that. I'm going to select the edge. The edge. This edge. Okay? And incidentally, this one is going to be fastened later on, as we discussed it in the earlier problem. Okay, so let's do a connection between the vertex here and the vertex there. So another connection. I'll call this thing left column. Left column. And plate vertex. Okay, so let me hide this. For the first component, I select this end and bring this thing in the show mode. I want to select this corner point here. In the second component, I want to select that. Let's see now. I'm not sure. Since I'm not sure which one I'm doing, let me hide this and hide this. There's a vertex. This chance of making a mistake here is minimal. Okay, and then another one. This one is going to be right column. Right column. And column. And plate. For the first component, let me hide the plate. First component is this point, and then bring this thing into the show mode. Hide the right column, hide the white dot, which is your connection that you're currently creating. So that guy. Alright, so let me now go and declare these things the way they're supposed to be. Okay. First of all, anything that we need to bring in the front, let's do that. Oh, what I meant was hide show, hide show, hide show. Okay, now fastened for the first one. Fastened means as if they were welded completely together, they move together, and vertex to vertex always has to be rigid. So rigid for this and rigid for that. I think we have taken care of everything, so let's run it and it will work. Notice that everything was done within a single part. I did not have an assembly. Okay, so first of all, save. Okay, and then run. I'm pretty sure it's going to run. Yep. Okay, so here's the deflection. That looks familiar to you. Okay, and there is a plane of symmetry that I did not use. I could have cut all of these into half. Basically, look at the second video segment. I'll use symmetry, except that I did not use a single part. I used an assembly. Please watch the second video segment. Now, I also mentioned to you that in the event that these are actually cables and not beams, so beams bend. In the event that those are cables, you need to go to properties, rigid properties, double click, transmitted degrees of freedom. Do not include rotation, because rotation is important if it's bending. And same thing with the other one, transmitted degrees of freedom. We discussed this thing in the second video segment, also in the context of an assembly. Okay, so this time if I run it, you will see that these columns, these are not going to be beamed, they're not going to bend, they're going to go straight down. So just watch what happens. There, straight down. Okay, and it does actually move. If you want to see the amount of movement, let's look at it like this. And for example, if you want to look at your beams, they're very tiny amount, so but there is color in there. Color means that they actually moved. So average ISO, and just don't show me everything, just show me the 1D mesh and the other one, and show it to me in average material shading right there. Now my graphics card will not produce the correct colors here, you will not have that problem for your computer. Okay. 1 meter stress. Now 1 meter stress, unfortunately beams do not display 1 meter stress, but if I plotted for example principal stresses, the axial stresses, you can see that because this is a stretching, there is an axial stress that it shows as a principal stress. Okay. Now I don't know, maybe if you want to see it in full average ISO color, right there. Again, these principal stresses are not displayed correctly. Alright, so this chapter 19 was done three different ways. The first one is assembly without, doing it as an assembly without any symmetry. Video 2 was assembly with one plane of symmetry, and video 3 was solving as a single part without any plane of symmetry. Also the difference between how it's done in the book and in all of these things that I did not use advanced meshing tool. I created the surface directly without actually creating a box type object and then extracting the surface.